Hi, my name's Nicholas Tate, and this is my YouTube video on variable length subnet mask. It's a way of subnetting an IP address to make networks. Let's begin by starting about talking what is an IP address. Okay, before we start VLSM, let's first discuss an IP address. An IP address is a 32-bit number that consists of 4 octets of numbers. Each octet holds 4 bits of information. An IP address also consists of a subnet mask, which tells the router what network the IP address is in. For this one, for example, is a Class C network address. As you can see, the slash format is 24, so its subnet mask is 255.255.255.0. Also, before we start VLSM, let's discuss the classes of networks. Okay, so this is a table of the different IP classes there are. I have 3 classes listed here. There's a total of 5, but let's only deal with these 3 right here. These are most important for VLSM subnetting. The first one is the Class A. As you can see, it ranges from 0.0.0.0 to 127.255.255.255. And the important part here is that in the Class A network, that the network portion of the IP address is in the first octet. And that's represented by the subnet being 255.0.0.0, or in slash format, /8. And below that, you can see my Class B networks, Class C networks. Class B is 128.0.0.0 to 191.255.255.255. And to represent that as a Class B, the subnet has to be 255.255.0.0. The first 2 octets of 255 representing the first 2 octets of the IP address being the network portion. And the slash format for that is 16. And of course, Class C being the first 3 octets are the network addresses, and the last bits are the host addresses. And the subnet mask for Class C is 255.255.255.0, or in slash format is 24. That path table is a very, very important table. That IP class table shows you the class boundaries of each IP address, each class of IP addresses. With VLSM, this allows us to subnet classlessly, so we can make the network bigger or smaller, give us more hosts, less hosts, as the person who's subnetting sees fit. Of course, VLSM allows you to, of course, make the network to your needs. Allows you to subnet classlessly, and unlike regular subnetting, you're not required to stick with the class boundaries. And I'm going to show you this in an example, and we're going to do a very, very easy example. So we're going to take this IP address, 192.168.0.0/24, and we're going to make 4 networks from this. Now remember, the subnet mask of this is 255.255.255.0, and that's represented by the /24. On each network, we're going to need these amount of hosts. On the first network, we're going to have 126 hosts. On the second network, we're going to have 30 hosts. And on the third network, we're going to have 8 hosts. And finally, on the fourth network, we're going to have 4 hosts. And to keep this from getting all confused, and it's easier for me to work with anyway, I like to create a little table that helps me keep track of everything. So if you're following along with me, go ahead and make a table. You'll need a network column, mask, /host, and a block column. And go ahead and label each network 1, 2, 3, and 4. Go ahead and keep that separated. After you do that, I'm sure you can already figure out that in the host column, we're going to put the number of hosts that are required on each network. This next part, where we determine the block size, could get a little tricky. To subnet this, we want to increase the subnet mask, and in order to find the block size, you have to know the placement value of the new subnet mask. So pretty much everything ties in with this new subnet mask, and we're going to go into subnet placement right now. So this is the subnet placement for this IP address that we're subnetting. On the first network, as you can tell, I've written out in binary so we can see what I'm doing. We needed 126 hosts, but the placement value is, the block size is 128. On the second network, we needed 30 hosts, and the placement value for that is 32. And on the third network, we needed 8 hosts. However, we needed a broadcast address and a network address, so that would need 10 host addresses. So the correct block size for that is 16, and the same thing on the last network. We needed 4 hosts. However, in reality, we needed 6 IP addresses, so we need a block size of 8. And as you can see, this is binary, and the 128, 32, 16, and 8 are written out. So now all you got to do is write in your block sizes under the block column in the table, and we'll continue on to finding the new subnet mask. Okay, so the new subnet mask is the new network address of the IP address you currently have, or will get. So the first new subnet mask is 255.255.255.128. That represents that the first 25 bits of the IP address will be the network address. And you get that by looking at where your block size is and adding the values up to that point. So you can, for example, network 2, your new mask is 255.255.255.224. And you got that by adding 128 plus 64 plus 32 together to get 224. Same with your network 3. The mask is 255.255.255.240. And you got that by adding 128, 64, 32, and 16 together to get 240. And network 4 will, of course, be 255.255.255.248. To find a new mask in slash form, all you have to do is count from the beginning. Count 1, 2, 3, 4, 5, and count where your ones end. And that slash form is where your network address stops. So, for example, the first network is 255.255.255.128. That 128 is the 25th one in that IP address. And you can do that on network 2, 3, and 4 to get slash 27, slash 28, and slash 29. And the last step we have to do is actually make the network addresses. And we start off with the original IP address with the new subnet mask. So network 1 is 192.168.0.0, and the subnet mask is 255.255.255.128. To find the new network 2 address, you add the block size to the first IP address, which is 128. So the new network address for network 2 is 192.168.0.128. And the subnet mask for that is 255.255.255.224. Then to the 128, to get the third network address, you add the 32 block size to the 128, and you get 160. So the network 3 network address is 192.168.0.160. And the mask value for that is 255.255.255.240. Okay. And I think we've subnetted this. Yep. Thanks for watching, guys.